Problem 23 says that as shown to the right, rectangle ABCD has vertices C and D on the x-axis and vertices A and B on the parabola y equals 9 minus x squared that is above the x-axis. So we want to express the perimeter of the rectangle as a function of the x-coordinate. So I have already some of this written out. So we want to find the perimeter as a function of x. So what does perimeter actually equal? Well, we're looking at a rectangle, so we're looking at 1 length, 2 length, plus 2 height, or plus 1 height and the second height. So we want to look for twice L plus twice H, or you can think about it as the width of the rectangle as well, whatever works for you. Well, the length, if we look at that, that's the distance from A to B, or the distance from D to C. Well, we know that the distance from the y-axis to A is x because of this coordinate A, which is x comma y. So if this distance right here is x, that means this distance right here is x, and the total distance then must be twice x. So for length, we're going to write in 2x. Now, the height of our rectangle from the x-axis up is just the y-coordinate, which is y. So we're going to write 2y. But we really know what y equals. Y is that parabola shape, which is 9 minus x squared. So we're going to substitute in 9 minus x squared for our y value. When we do that, we can simplify. So we multiply 2 times 2, so we have 4x. Distribute this 2 all the way through, we have 18 minus 2x squared. If we want to rearrange that, we can just say P equals negative 2x squared plus 4x plus 18. That is the perimeter as a function of x. So we are done. The next part asks for the domain of our function, of our perimeter function. So we should look at this as how big can our width be and how small can our width be? Because the domain refers to the x, and the x was our length. Okay, so I was saying width, so I should have been saying length. So how long can our length be? What's the maximum it can be? So we're always dealing with this x coordinate over here. So we're always looking at the positive. So we're always looking at this side of the graph. So the widest it could be is 3. But if it was 3, that would mean that we're exactly on the x-axis, and therefore we wouldn't have any height whatsoever. So our domain can go up to 3, but it can't be 3. So it can go up to, but it can't be 3. Let's think about how small our width or length can be. We can go all the way into 0, because remember we're only looking on this side of the y-axis, so on the right side of the y-axis. So how small could it be? It can't be 0, because if it was 0, it would be right on the y-axis, and that would mean there's a length of 0, or a width of 0. So it can go up to the y-axis, which would be x equals 0, but it can't be on the y-axis. So our domain is going to be x such that 0 is less than x, which is less than 3. So the domain can extend from 0 to 3, but it cannot include each of those. And then it asks us to find what is the maximum perimeter. Well, you would go ahead and type this into your equation, your perimeter equation. That's going to be a parabola that looks something like this. Remember that when you draw in the axes, here is x, this is perimeter, and we're asked to find when is the perimeter maximum. So it would be whatever that point is, and it would be the y value of that point. And that is actually going to be, we're looking for the x value where the perimeter is a maximum. So you would be looking for the x value. And that happens at x equals 1 if you use your graphing calculator. So that is all there is to number 23.